So in today's video, we are going to see heap sort method. Okay. So before we are coming to heap sort method, what is the definition of heap sort method? It is heap sort is a comparison based sorting algorithm that uses a binary heap data structure. What do you mean by binary heap? Binary heap data structure, it is nothing but we are taking a binary tree. Binary tree, it is nothing but if one parent is there, only two children are allowed. Okay. If third children it comes, it is not a binary tree. So binary does not by it is nothing but 2. Okay. So binary heap data structure. So as far as the heap sort is concerned, we are able to sort the numbers in two methods, in two ways. The first way it is max-heap method, another one is min-heap method. So what do you mean by max-heap? Max-heap, it is nothing but parent value should be greater than the two children. So suppose we are taking this example. So in this example, what is it? The max-heap, it is nothing but the parent value it is 18 and the children value it is 12 and 14. So parent value is greater than the both the children. That is, we call it as max-heap. What is min-heap? Min-heap, it is nothing but parent value should be lesser than the two children. So in the min-heap, so just you see the value, 12 is a parent value, 18 and 14 is the children value. So parent value must be minimum value than the two children. Whereas in max-heap, parent value must be greater than the two children. Okay. So this is what the idea. So now we are going to construct a what is that? Max-heap tree. Okay. So suppose we are taking this as example. From this example, I am going to construct a binary tree first. Then we are going to convert it into corresponding max-heap. Okay. So what is that numbers? The numbers are 26. We are taking the first number and we keep that first number as a root number, root value. That is root node of the tree. And we are taking second number it is 5. Second number it is a left subtree of that particular root. And 77 is a right child. Okay. Then third number is 1. 1 means we are unable to insert here because as per the binary tree rule, only two children are allowed. So that's why 1 automatically comes here in the next level. So it is the left child of parent 5. Then 61 comes here as a right child of 5. Then what is 11? 11 is a left child of 77. And next number 59 is the right child of 77. Okay. Then after 59, 15, this level is also over. Okay. It comes level by level. And we go to next level and 15 is the left child of parent 1. And 48 is the right child of parent 1. And the next number is 19. 19 is the left child of 61. So this is what the construction of binary tree with the given number. Okay. So now what I am going to do means I am going to construct this tree into the max-heap tree. How we are constructing? So the max-heap is we go to the what is it bottommost level, and from the bottommost level I come by one level up. Okay, one level up until we reach the root node. Okay, so what is the last level? We come from right to left because it is the 19 is the last level, last number. So 19 is compared with 61. What is the value of 19? It is lesser than the what is it? Parent 61. So we won't disturb anything. We keep as it is. Then we come to the previous node 48. When we are having single node, we compare directly with the parent. Suppose two nodes are there. We have to compare these two nodes first. Okay. 15 is compared with 48. So 48 is the bigger number. 48 is compared with 1. So 1 is a lesser number. 48 is the greater number. So that's why we are constructing what is it? 26 5, 77, 1, 61, then 11, 59, then 15, 48, then 90. Okay. So this is over. Then we come here 48, 15 compared, 48 compared with 1. So 48 is transferred, it is swapped one another. So 48 comes here, 1 comes here. Okay. This level is over. Now I come to the previous level. When I come to the previous level, I am not taking these two nodes. First I have to take from right to left. So whenever I am comparing, I come from right to left. So 59, 11. So 11 and 59 is compared. 59 is a bigger number. This 59 is compared with the parent node 77. Already 77 is a bigger number. So that's why we are not doing anything in this turn. Okay. Then I come to 61 and 48. Next to two nodes. 61 and 48. So 61 is a greater number. So 61 is compared with 5. So 5 is a lesser number. 61 is a greater number. So that's why 5 comes here. 61 goes here. Whenever before we are inserting 5 here, it is having some child. So that's why it is compared with child. So what is the child value? Child value it is 19. 5 is a lesser number. So that's why 19 goes here. Then 5 comes here. Okay. So before that what we do? 5 is here. We have to check it up. Any children is there? There is no children. So that's why 5 is stored here in this node. So now this level is over. Now I come to the previous level. 77 and 61. 77 and 61. 77 is a greater number. 77 and 26. 77 is a greater number. So that's why 26 it comes here and 77 goes into the root node. Okay. So I already told you before inserting 26 here, I have to check these two children. 59 and 11. 59 is greater. 59 is compared with 26. 59 is greater. So 26 is lesser. So that's why 59 it comes here and 26 is stored here. Is the point clear? So now what I did means I am taking the numbers, I am constructing a binary tree. After constructing a binary tree, I used to convert that binary tree into max-heap binary tree. So this is we call it as max-heap binary tree. So this is what max-heap binary tree. Okay. So after finding the max-heap binary tree, we are applying the rule level by level from last level to the root level. We confirm that 77 is the, what is it? Biggest number among all the numbers. Okay. So now what I do means I have to transfer this 77 into the last node. This last node value is transferred to the, what is it? Parent node, sorry, root node. Okay. So these two are interchanged. So what is it? 77 comes here, 5 goes here. Now at the time of second iteration, one iteration is over. In the second iteration, we are not including this number because it is sorted. What I do, what at each and every iteration, what I do, I have to take the maximum value to the root, then root is, what is it, swapped with the last node. So what is it, 77 is transferred here, 5 comes here. Once again we apply the same max-heap binary tree property. What is it? In this level there is no change because 15 and 1, 48 is a bigger value. 26 and 11, 59 is a greater value. 19 and 48, 61 is a greater value. Now 59 and 61, 61 is a greater value. 61 compared with 5. So 61 should be here. 5 must be come here, but before that I have to, there are two children are there. I have to check 48 and 19. 48 is a greater value. So 48 is transferred here and 5 is coming here. I am unable to store immediately because it is having two children. So that's why I have to check 15 and 1. 15 is a greater value. 15 compared with 5. 15 is greater. So that's why 15 comes here. 5 must be stored here. After checking, there is no children available. Okay, this is what the next iteration. So after completing next iteration, what I do? I have to take this particular next node of last node. It is 1. So 61 is coming here and 1 is swapped to root node. And in this time, this node is also rejected. It is not compared because already it is sorted. So what we are doing like this way, what we are doing means we are taking the highest value at each and every time the highest value comes to the root and it is transferred into the appropriate position. Okay. So 61, 77, then 1. These two is not compared. 5 is compared with 15. It is in order. Max-heap order. 26, 11, 59. It is in order. 19, 15, 48. It is in order. 59 and 48. 59 is greater. 59 compared with 1. So 1 is transferred here and not at transferred. 59 goes to the root node. 1. Before 1 is stored in this node, we have to check the two children 11 and 26. 26 is greater. 26 compared with 1. So 26 is transferred here. 1 it is stored. After checking, there is no children. Okay. So this is what the next iteration, that is third iteration. Whenever the third iteration is over, what we do? The next highest is 59. So the 59 and 5 is transferred because these two are already ordered. So that's why 59 comes here. 59 comes here and 5 goes to this node. So this time this is also eliminated. Next time what we do, 11 and 1 compare, 26 greater value. 19 and 15, 48, it is in order. 26, 48, 48 is a greater number. 48 compare with 5. So that's why we have to transfer 5 here. 48 comes here. Before storing 5, we have to compare these two children, 15 and 19. 19 is a greater value. 19 and 5, 19 is greater. So 19 comes here. 5 goes here. This time I am not checking with 77 because it is already sorted. We eliminate. So that's why 5 goes here. After that what we do, 48 is the next greater value. What is the next node? Next node is this node. So 48 comes here. 1 goes again into the root. So 48 and 1. This time this node is also eliminated. Okay. So once again what we are doing, 15, 11, 26, okay, 5, 15, 19, okay. So 26, 19, 1. So 26 is greater than 19 and 26. So 26 compared with 1. So 1 comes here, 26 goes here. Then 1 is compared with 11. 11 is a greater value. So 11 comes here, 1 goes here. What we do? Another iteration is over. Now I am going to take the 26 and I am replacing into the last uneliminated node. So 26 comes here, 1 goes here. So this is also eliminated in the next time. So what we do, again we are doing the same thing. 15, 5, 19 is order. 19, 11, 19 is greater. 19 compared with 1. So 19 goes here, 1 comes here. And we are doing 5 and 15. 15 is greater. 15 compared with 1. So 15 comes here, 1 goes to here. Okay. So what we do, it is over. Then after over, 19 is transferred with the next uneliminated node from last to first. So 5 goes here, 19 comes here. 5 goes here, 19 comes here. This is also eliminated. Again we are doing the same thing. So this level we don't need to do anything. 15, 11, 15 is greater. 15 compared with 5. So 15 comes here. Okay. Then before we are storing 5, we compare with 1 only. It is already in order. So that's why 5 comes into the actual position. So what we do now, 15 comes here. This iteration is over. So 15 comes here, 1 goes here. So that's why 1 comes here, 15 goes here. Then I am eliminating this also. Now we compare 11 and 5. So 11 is a greater value. So 11 compared with 1. So what we do? We are doing 11 comes here, 1 goes here. So what we do? The next from last it is next is 1. So 1 and 11 is interchanged. So that's why what is it? This 11 comes here, 1 goes here. This is also eliminated. Now we have to compare 5 and 1. As per the max-heap property, 5 is a greater value. So that's why 5 comes here, 1 goes here. After this iteration is over, 5 should be interchanged with the from last to left. So that's why 5 comes here, 1 goes here. This is also eliminated. Okay. So after doing all these steps, we are taking the number from root from left to right. What is it? 1, 5, 11. What is it? 5, 11, 15, 19, 26, 48, then 59, 61, 77. So it is in ascending order. So through this way only we are arranging the number in max-heap. What is it? Through the max-heap binary tree rule. Okay. So this is what the idea. I hope you understand the logic. In our next video, we are going to see the algorithm for this heap. Heap sort method.